Yes, I have a question. I just posted it on Slack, but maybe I can just say it orally.
Yes, please go ahead.
Okay. You showed some numerical results with the finite but large number of agents in the system, and I was wondering if you had a more general intuition on what happens between the two regimes that you looked at, the case of two agents and n agents, and if you find a way of gathering them.
Okay, thank you very much for questions. In this study, I have analyzed only two extreme cases because the middle of two extreme cases are very difficult to analyze. So this is the next target for my research. So at that moment, I don't have any result when the number of agents is finite rather than two.
Okay, thanks. And thanks for the talk.
Thank you very much.
Okay, are there any other questions? Okay, so very nice talk, and I have a quick one. It's actually kind of, I'm not quite familiar. Can you give us like what's the intuitive understanding about this W? Because you showed how W different coefficients.
W.
Yes,
W. W is a parameter expressing the degree to which how each agent is influenced by the received opinion. Neighbor agent, in other words.
Okay.
If W is equal to 1, agent believes the received opinion completely, and if W is equal to 0, each agent does not change his opinion, even if he receives the opinion of neighbor agent.
Thank you. So the other question is how the connectivity of the graph, for example, would influence
graph. The main result of this paper is derived only when the topology of the network is mesh. I mean, any pair of agents can be communicated directly. And if this assumption is relaxed, I mean, for any topologies of the network, I don't have any specific result. I think this is very difficult. And it's a next target of my research, I think.
Thank you. Because I think there are results showing given connectivity.
Not a given connectivity, just meshed. Yeah.
Just meshed. I see. Okay.
Yeah, just meshed. Yes.
Okay. Thank you. So any other questions from the audience?
Maybe one again. Okay. So also about the parameters and the general settings. I was wondering, do you know if in your case, as far as I understood, you assumed that the values that the agents could choose were continuous, for instance, any value between 0 and 1?
Not limited to between 0 to 1. Each agent get to any real number, any real value.
But do you know if your result could be naturally adapted for discrete values? For instance, if they not voting, but if they have only a limited number of values to choose from, 0 to n or something like this?
For example, if the initial opinion follows Gaussian distribution, each agent can get opinion which value is negative. But, for example, Levy distribution, each opinion should be positive value, but it opinion can get any large values, not limited to, not less than one.
Yes, sure, but I meant integer values.
Integer value. If the yes. For example, if the number of agent is finite, opinion can be limited to the integer value, maybe.
Okay, thanks.
Okay, thank you for all. Due to the time limitation, we will not continue the Q&A session. So if you have questions, you can send, all the speakers, by email, your questions. So let's conclude the session. Let's, give a big round